The validation and verification activity. Write an algorithm that would validate the gender of a user, where the valid options would be male, female, or other. So we've got 3 potential valid options. What we need to do is write an algorithm that uses a lookup check. Now here, I've got a function called validate gender, which takes in gender as a string and returns a boolean. So true or false, depending upon if it's valid or not. So we say, if the gender's male, or the gender's female, or the gender's other, then we'll return true, saying it's valid, or else we'll return false, saying it's not valid. And that could be built into a while loop then on the other end of the code to see what happens, or return an error message if it returns false there. Write an algorithm that will traverse this 3D array and only output the subject and room numbers. Now this is a little bit trickier because you need then to understand how the columns in the array work to get this working at all. So the first thing, we need only 2 for loops here, an I and a j value. The I represents which of those 2 tables we're looking at, so it's the level. The j represents the row, and then instead of having to iterate through the columns, because I only need to output 2 of them, I've manually coded those into there. So I'm outputting column 0 and column 2, and it does it row by row. So I should get English, A1, maths, whatever room that is, and it should go through that first table in order, that second table in order there. Compression activity. I like this question a lot. Humans can detect frequencies between 20 Hz and 20 kHz. Explain how this might be used in the compression of audio and why this might be considered problematic for the quality of the audio. So you've recorded a concert and it's in uncompressed WAV, and the concert is some ridiculous amount of gigabytes and you want to get it down to a smaller size. How could we use that knowledge to compress it? Well, you could actually remove all the frequencies recorded below 20 Hz and above 20 kHz and just throw them away. To a normal human, that wouldn't sound any different. And that's actually how they do it in most audio formats. MP3 does something similar. Now, it wouldn't be noticeable to humans in the most cases, so both files would sound the same. And it's called lossy compression because we lose some element of the data as we do that. The problem is that the quality of the audio is technically worse because we have thrown that data away. We will never be able to recover that data.